Maybe that's a Friday afternoon thing, I don't know. We are kicking off a panel. You're in the room where all the fun's going to happen actually on smart contracts. How many people doing anything using a smart contract today? Oh, I saw one hand too. Oh, of course, yeah, there you go. Hyperchain Labs. Go chat with them after, please. Right there. Yeah, and you guys are as well. Okay, so awesome. So, yeah, it's real. Here's a test for you. Ready? It's an important test. Are smart contracts just for lawyers?
No.
Okay. How many people say no? Raise your hand.
Panel really short.
Yeah, I was going to say. Perfect. Of course not. Right. It just happens to be the name. All right. Why don't you guys come on up? We got Bowman back from Blackwell. Peter Hunn is here with Claus. Howard, you're here? Yep. With Hitachi Vantara. And then also Melanie Cutlan is here with Accenture. They have some stuff to drive you through, but then please be ready for questions. And I would say ask some pretty challenging questions. What do you think?
Sure.
All right. Perfect.
I'm game. All right, for all of those who weren't lucky enough to spend 30 minutes learning about GDPR and CCPA, I'm Bob Bowman, partner with the law firm Husch Blackwell, located here in our Denver office. I do a lot of technology law, is kind of how I describe it. Do some patent work, do some data security and privacy work, a lot of software licensing and development agreements, negotiations, which is now becoming just as much about the data being generated and transferred in as the actual software itself. So my interest is from a legal perspective, a working attorney perspective on smart legal contracts, and how they can benefit our clients and benefit us as lawyers. I'm not of the nature that it's going to disrupt my career, hopefully, at least not. I only have about 20 years left, so hopefully I won't do that. And hopefully AI will stay away for that long. Anyway, so I'm going to go let each panel member introduce themselves, and then give a little bit of background of where you fit in the perspective on smart contracts. So when you have any questions, we can direct those to the applicable party.
Great. My name is Peter Hunn. I'm the founder and CEO of Clause. Those that were in the session this morning, you may be familiar with, hopefully familiar with what we do. Essentially, we build smart legal contracts infrastructure so you can run contracts that are both human readable and machine readable, and you can connect them to a variety of enterprise services. So you can connect them to blockchain systems, you can connect them to CRM systems, ERP systems, invoicing systems, and you can essentially wire up all of your infrastructure through a contract. Because today, our contracts are static PDF documents, and we don't have any form of integration with external systems. So that's essentially what we provide.
So I'm Howard Holton. I'm the Hitachi Vantara. You might know us as Hitachi Data Systems. Renamed about 2 years ago, I guess. Hitachi Vantara, CTO for smart city, public safety, smart spaces, as well as compliance, governance, and legal. So I consult with government agencies and like the Fortune 1000 on their IT strategy, data strategy, digital strategy, and digital transformation, of which blockchain is a huge piece because it's starting to show up in 10Ks, it's starting to show up in board meetings, it's starting to show up in things companies want to do and they haven't got the slightest idea how to start. So I recommend no about 95% of the time.
Thankfully, I have teams that now filter out the nose, and I get the yes. That's what I was last year. I'm Melanie Cutlan, and I'm with Accenture. I happen to live here in Denver, which is awesome to be here locally. And I lead a practice in blockchain and operations and all enterprise functions, if you were able to hear me yesterday. But I have an interest in smart contracts, not just from the legally enforceable side, but where they are a unique innovation that is allowing us to drive business automation across ecosystems, across parties, like we've done in the waves of automation, right? We've done RPA, we've done AI, right? Take away your job, the next generation, right? Many generations ago. But how smart contracts start to help us rethink about how do we do a common business process across multiple parties. That's where I get really excited about here.
Excellent. So kind of we heard two different concepts. Peter was talking about smart legal contracts. It's kind of where my perspective is. When you have smart contracts, which perform some of the same functions, maybe just not legally enforceable or not able to be pulled out so that the terms can be reviewed by a jurisdiction that they can make a decision on. So Peter, can you give a little example more of like smart legal contracts, that definition, and then maybe I'll kick it to Howard and Melanie, kind of from your perspective, some practical examples of smart contracts from your perspective.
Sure. So, a smart legal contract, in our view, is essentially a composite of natural language and machine-readable language, so that we can create these contracts that are both human-readable and machine-readable. So we can understand them as humans. We can take that contract to dispute resolution mechanisms, but also machines can understand that agreement to automate certain processes that occur pertaining to that contractual agreement. So that could be executing transactions through blockchain infrastructure, so digital currency transactions, digital assets that exist on the chain, moving them about in a verifiable way pursuant to that contract. Or it can be off-chain systems, so connecting that smart contract, or that smart legal contract, to payments processes like Stripe, to invoicing infrastructure, so you can raise an invoice in real time based upon some external event. So that could be a delivery event, for example. We can track the delivery using, say, FedEx's system and pull in data from their API to kick off a process through a contract that will then have downstream implications. So it's about taking static natural language contracts that we have today, adding computable componentry within those contracts to enable us to add business value effectively. And that can be on blockchain systems, or it can be outside of blockchain systems.
That's a really good description of smart legal contracts. I like that. Hopefully it's being recorded in exchange for something else, right? And that's ultimately what a contract is. We do that 1,000,000 times a day in business, and most of our business processes are built around some sort of contractual agreement, right? I need this from this department to accomplish this thing. I need this from this supplier to accomplish a thing. And ultimately, the goal is to remove the human barriers, in just like we do in any other BPA. Remove the human factor from that when a human doesn't necessarily need to make a decision and yet is still a roadblock. That's the number one kind of big use case I see for smart contracts long term. And since I focus a lot of my time on government agencies, think about a city. A city is a really good example of this, because a city is not one thing. It's 24 plus organizations, none of whom are really beholden to each other. Theoretically, they're beholden to the electorate, to the citizens. Right? So how do I get some number of those 24 people to agree on an assessment, unassessed value, a property tax arrangement, how to spend money, how to enforce laws, how to enforce rules, what a regulation should be, how a permit should be enforced, or if a permit should be issued. And currently, it involves some percentage of 24 different organizations looking at a document and clicking yes or no eventually. And most of the time, there's no thought put into it, right? It's almost a rubber stamp. So shouldn't we automate that, provide that feedback back, and remove some of those roadblocks? And that's kind of where I see some big value in this space in 30 seconds.
Well said. I think it's funny because in our academies we actually talk about, well, what is a smart contract? It's neither smart nor it's a contract. Right? In its general language, like what many of these blockchain solutions have put in place, and you saw the stacks from R3 earlier today, right? There's a persistence layer, right, where your data is stored. There's a shared business logic layer, and there's a shared perception layer, right? And a lot of that is that work orchestration, that intelligence, that business logic. That is, once you trust business logic, you're good with it continuing on and on without you. And so you got it's all about finality, right? Deterministic capabilities of the technology. And so many technologies, if you run the same code a bunch of times, you won't always get the same answer, right? Like it's depending on the sources you use. If you run them in different places, you won't get the same answer. And so smart contracts are really allowing us to get to that deterministic. You use it in scenarios when you're in a deterministic area that you actually come to the same outcome no matter who runs it, right? So my central server runs it, gets an output. somebody else somewhere else runs it, they get the same output, and that matters, right? Because that we weren't able to do that in business today because, right, FX was Dan's example this morning, is we all have different FX tables, et cetera. So I think smart contracts are a capability that is allowing us to look across an ecosystem and say, where can we use this capability? And I love that now we're taking that innovation, and people like Clause.io, right, are building on top of it and saying, let's take this new cool coding capability and make it applicable to the legal space in a way that is consumable by a business user, because that mapping of, you know, do I have to interview a developer and run tests on it before I can trust it and say it's enforceable in law? It's nice to see some coming together. So just to be clear, when we answer and talk about smart contracts, there's the general, this is a cool innovation in development, right, and developers and what they can do. And then there's the layers on top that are people are putting on to make it business relevant and easier to make it legally enforceable. Because I talk to a lot of clients and they're like, if you put this contract on my blockchain, is it got to be legally enforceable? If not, go away. Right, back to the no. Thank you, but no thank you, right? And so the ability to start to get to those with those innovations, I think, are really helpful.
Yeah, that's great. I mean, so the theme I'm picking up is efficiency, and someone who bills by the hour. You know, that's not something I like to hear. But and I was talking with Peter, you know, kind of off stage, and I was just thinking about, you know, contract life cycle. He has some statistics that will blow your mind about how much money is spent by a company on the back end, not only with your lawyer negotiating the contract up front, but then, you know, all the manpower and time going up and down the line, like you were saying, do people get sign-offs and just things like keeping track of when does a contract expire. And with, you know, smart contracts, not really replacing the legal part, because those terms will be laid out, but those will connect down the road. I see that as a big proponent of pushing this to my clients, because it doesn't really take away from my work right now. But if I am considered helping them make more money, they're going to keep coming back. And so from the building on top of that layer, I think, you know, that these legal contracts are fascinating to me, and I like, you know, all of your explanations of how that becomes more efficient. Can you guys kind of, you know, I know you gave a bunch of examples this morning. Maybe give one example, each of you, kind of where you've seen a practical implication or a practical effect of a smart contract and how it's created efficiencies. You can just start down with you, Melanie. We'll work our way back.
All right, I got a microphone. Danger. I can talk forever, that's a problem. So we did a release with software entitlements, you mentioned. So just bringing that top of mind last year, and it really had if you think of an entitlement, it's a token, right? And there's a challenge between, you know, and today, you know, you think of the old flip them open and you look at the code in the back and you've now verified your token to unlock software, right? And it's easily digitizable, it's easily transferable. You can think about it that way. And we quickly went to, this is a great way to say, how do I make sure I don't double spend a license? In an organization with 450,000 people now, which is massive to think we're that big. But our vendors are worried that we're, you know, handing out these codes, right, and sharing software. I feel like the microphone is catching out, but okay, maybe it's just me. So it was an easy place to start with saying we can digitize a token for a license for a piece of software. It's really easy to understand, but now we can put smart capabilities in it. This license is enabled to do more than other licenses are enabled to do. So we can start to put rules in place and actually execute them and have them self-execute to say, do you have the rights to do X, Y, or Z? In a lot of scenarios, some cloud software is getting in that space today, but it was a great place to start. You know, we did early innovation and took it to production where we can make sure we're not double spending a license. We can show our vendors that we're not double spending them across our user base, but then also bring in that intelligence that says, as you know, you are approved to do more and such. So it kind of brings in both of those layers together. I've got a persistence layer we all trust, but now I have a capability to share what are you able to do through that capability.
Okay, so how many people in the room have bought? This feels like it's cutting out it, like I didn't even move at that time. So how many people in the room have bought a new or certified pre-owned car? All right. How many people have bought an extended warranty on your car? Or a maintenance agreement, or a service agreement, or 3 or 4? Okay. For the rest of you, the auto industry would like to have a word with you. There'll be 3 used car salesmen standing outside the door when you go to leave. Oh, head out again. Apparently, nobody likes the car salesman spiel. Anyways, one of the more difficult things to do in that situation is what does that cover? What does it not cover? And when does it expire? And the goal there is not only to inform the purchaser in a real contractual sense, right, with something a little bit better than the little flip tri-fold brochure they give you, but also to be able to automate the renewal process, because currently that's completely and totally broken. When your car comes up for an expiration of warranty, 1, the automaker would really like to see your car again right before that happens, and 2, they want to automate the ability to reach back out to you and try to sell you another warranty. The best way to do that, and the reason smart contracts make sense in that case, is we can automate that process kind of end to end. And if you're willing to accept the price, fine. We can give you the ability to renegotiate the price, and if it falls within certain parameters, automatically approve that negotiation, and then update all the connected systems throughout without having to really interrupt you by having you bring your car down, get you in front of a person, go through the whole sales process, and add the pressure. So that's kind of my favorite real-world use of smart contracts.
I've got a bunch that I'm particularly passionate about. So, I mean, there's a whole spectrum of applications here, which is really exciting. So we've worked from just automating basic NDAs with no blockchain infrastructure at all. So you can send a notification based upon expiration dates within an NDA, or notifications to auto-renew that NDA. And you can just do that, party side in your own cloud infrastructure. You don't need any shared blockchain infrastructure to provide for that. You can, if you wanted to make sure that both parties or multiple parties were aware of the state of that contract effectively in real time, you could distribute that as part of a distributed audit trail on a DLT system. So that's one very basic use case that we deal with on a day-to-day basis that adds a lot of value, being able to have this real-time state of what a fairly standardized contract, up until sort of like the far more complex use cases where we're executing legal contracts, supply contracts on top of a supply chain network. Take IBM's Food Trust, for example, where we want to have a blockchain infrastructure communicate with our legal contracts so that we can track the state of that agreement throughout the entire life cycle of that sales contract. So we could effectively instantiate transactions on a blockchain to track the location of goods and the shipping conditions of those goods on a DLT infrastructure, and we can essentially use that or consume that data into the legal contract itself, so we can compute some state and then push that back onto a blockchain. So, for example, we could use an event which is stored on a blockchain and input that into a contract to track compliance with the terms and conditions, and then we can transition the blockchain network based upon the output of those legal terms and conditions. That's really, really powerful because it enables us to connect our legal contracts with DLT infrastructure in such a way that we're using the two together without significant changes to one or the other. So I think there's a bunch of really powerful use cases from basic contracts to sort of more complex contracts.
Now that you're down, the microphone should
be
So I'm actually going to steal an example from Claus's sort of website that kind of excites me because I have spent time negotiating with software vendors for uptime warranties on software contracts. I think at the end of the day, that's about all the attention that those get usually. Unless something catastrophic happens and they go back and just because it's very time consuming to have the person in your ID department go and check the monitoring software and figure out where they're at. So one example that they said was just having an input of that availability on a regular time, whether it's a daily, a monthly, or whatever, and then automatically generating an invoice for the credit. So, I mean, it's something kind of very simple, but it shows the efficiencies that just at the very tip of smart legal contracts can give you. So I think, are you guys ready to field some questions?
Sure.
All right. Anybody have any questions?
Just briefly. Melanie said that smart contracts aren't necessarily smart. I was going to add a direct what's the difference in the law between clickbait and smart contracts?
I'm not sure it's a connection. I think we're going to need a little bit better explanation of the question.
Okay.
Because how are you connecting clickbait and smart contracts?
Well, clickbait is if somebody says, makes a proposition of if you do this, you click this and get X. Necessarily, you have an if then and promise and obviously your time consideration.
So I think the question is, what's the difference between a generalized promise and a smart contract under the law?
Well, if it's a smart legal contract, there's no difference because you have an understanding, like you were saying, of offer and acceptance. That's really legally what makes a contract. So clickbait, is an offer, and the acceptance is click here. That's how we get all the consents for agreeing to privacy policies as well. So, but yeah, I mean, from that perspective, the basic of a contract is offer and acceptance and consideration. Is there something being exchanged?
So a smart contract is essentially a script on a DLT system can be a legal contract, right? Most jurisdictions could recognize that as a contract enforceable at law. But to Melanie's point, it doesn't necessarily follow that a smart contract is a contract at law. Right? You could have just a smart contract that exists on a blockchain that increments a counter whenever somebody clicks a button, right? It's essentially a stored procedure that exists in a database, except that this is a distributed database with consensus, so that we can all see the state of that network. So that would be my comment: is that there is some overlap, but it doesn't necessitate the fact that just because you have a smart contract that's legally enforceable.
This gentleman here also has a question.
In two parts. I guess the first question is what happens when a smart contract is a dumb contract, i.e. there are bugs in it, and to what level of sophistication is realistic in the context of, say, Turing-complete solutions to this particular problem. And I was also wondering, there's a plethora of potential smart contract languages up there, and the blockchain insurgency keeps asking me which one is the best. And it's just exhausting. Do you have any opinions?
Oh, I think the lawyer should answer which one's the best and dumb contracts. I'm not trying to get specifics from attorneys.
Yeah, I think you're probably all answering this question, right? I think there's a ton of products out there, and some are full Turing complete, and I'm not sure is yours.
It's purposely not true.
Right, so I get excited about the ones, like I've done some work with Daml and Digital Asset that's not full Turing complete, because it means you can't get yourself outside the boundaries of technology. Like, so you can't code yourself far, far away, right? You purposely can't do every piece of code possible. Those that are closer to business consumable are the ones that are my favorites, right? Where you can actually consume them in that space, I think, from that part of the question. But I think there's an important part about governance, right? So you're taking what used to be a centralized solution, and if you take a centralized solution, if there's a bug, you can shut it down, you can call a help desk, you can do a disaster recovery business continuity plan and get something in place. But now we are putting code that self-executes around a network. And that is new, and that is different, and that requires somebody has to be in charge, right? You lose a $2 million transaction, you better as heck be able to call somebody and say, what's happening? Where did my money go, and what am I going to do about it, right? So I think as we think about smart contracts, it was very early days, like 2016, we told people to avoid them because it was actually, there wasn't a governance structure that said someone's in charge. And so some of the unpermissioned public blockchains make me very, very nervous because there's nobody in charge to say if this is wrong. And now and also to mention, like, if you've got a bug, it's identified, you have to have a governance model that forces people to adopt the next version that closes that bug. Right? So you have to be able to say you can only now contribute to this network if you've now upgraded your solution to the next version, which is safe from safeguarding those things. So I think governance is really important to that entire model. Just because we're getting to a distributed world doesn't mean we're getting to an unpoliced world, I would say.
Yeah, I would say the two things that make a dumb smart contract implementation is not understanding how it changes business continuity and not understanding how it affects governance and compliance. GDPR is a fantastic example. So is the 27 countries that are essentially photocopying GDPR. I think Brazil was the first to legislate it, where they did a find and replace and simply replaced EU with Brazil. It was kind of amazing. But ultimately, if you had any of that data on the ledger and GDPR comes out, what do you do the first time someone says, I want to execute my right to be forgotten, and you have to remove that data? It's immutable. Okay, cool. I've added another record that says, go away, but it's still there. The data hasn't been deleted. So have I complied with the law? Have I not complied with the law? Do you really want to find out in front of the commission? Do you really want to find out in court and risk 25 million euros or 4% of global turnover of your parent company? That's one thing I didn't hear. It's 4% global turnover of the parent company. So as Hitachi Vantara, I'm part of 826 companies that report up to Hitachi Limited. It's 4% of Hitachi Limited's global turnover if I mess up. I don't want to do that.
We've got great redaction solutions to help you with that.
So my answer to both questions would be architecture. So what is a dumb smart contract implementation? Well, that's, if we're talking about legal contracts or smart legal contracts, that's just putting everything on chain, in my view. Because you don't want to do that for a number of reasons that I mentioned this morning, is that a smart legal contract has, by definition is enforceable at law, and we've got a bunch of regulations and legal principles that apply to that smart contract. So what happens if that contract is vitiated in some way? We want to reverse certain transactions that have occurred. It's very difficult to do when that's done in a mutable, decentralized fashion. What we actually want to do, in my opinion, is start to execute or compute the state of these contracts off-chain and have side effects that occur on-chain when it makes sense. So this is my short answer for dumb implementations. And in terms of languages, I would say that actually there's a bunch of languages that exist at different points in the stack. So if we're talking about that sort of off-chain, on-chain hybrid implementation, what we provide at Clause is a language, a DSL, domain-specific language for writing the logic of the legal contract, but then you can have languages that effectively define the workflow at the ledger layer. So DAML is one example, Solidity is another example, and you can actually call those smart contracts from the legal contract itself. So we're using languages where they make sense in the stack, not just a single purpose universal language.
Awesome. Well, I'll give my short perspective on that. A dumb contract is what I work in every day. And from a lawyer's perspective, a dumb contract is one that can't be changed based on the circumstances, and can be changed based on an inadvertent error in the contract. And I think Peter and Klaus have developed some deployment strategies which try and mitigate that risk. I think we're probably up on time here. So maybe one more question, I guess, real quick.
Can we go back?
You guys are describing the contracts that you use here. It's a workflow. It's just a workflow along the edges. When I describe to clients, they get confused that your contract, they get terrified. This is just an advanced workflow that can tie to multiple systems. Is that wrong in your opinion?
I think it comes back to the architecture point. So at what point in the stack are we talking about? So our view is that you have these legal contracts that are composite of natural language and executable logic. And what we're doing is we're computing the state of that agreement relative to some external event. Right, so that could be an on-chain transaction may interface with a legal contract to perform some output. So when a transaction occurs on ledger, the legal contract will check that that's valid, for example, or perform some computation that you can connect to an external system from. And in my view, that what we're doing is actually we're computing legal contracts at the sort of the upper layer, and the lower layer is essentially the workflow, shared workflows between parties that may be parties to that legal contract or may not be, but that legal contract has some relevance to that shared infrastructure.
I would say you're not wrong. I mean, my definition was it's an agreement to do a thing based on a thing. So the smart part is just automating that, right? Using some sort of logic.
I think it's an agreement to do a thing and a thing that is tied to the persistence layer.
Correct.
And that tying it to a persistence layer that is shared is what's new. Because we used to share it to, it was an unshared thing to do a thing. I interpreted it my way, I wrote it in my database, you interpreted it your way, you did it in your database, and we didn't have that shared view of it. It's down to the persistence layer, to your point of the stacks, right? That makes that, I agree to do a thing to do a thing, and we're doing it in front of a crowd, right? So that we can all see the answer, and we all now trust that answer.
Well, thanks everybody thanks Melanie, Howard, and Peter for your input.